Welcome everyone. My name is Peter Dalbunjan and I'm a Senior Container Specialist Solutions Architect at AWS. My role here at Amazon is to work with customers who are deploying and managing container workloads at AWS. In today's webinar, we will review how to run successful Kubernetes deployments on AWS. Let's get started. So here's the agenda for today. We will review multiple Kubernetes cluster setup options available on AWS. And then we will cover Amazon EKS, which is Amazon Elastic Container Service for Kubernetes, in detail. Now, Amazon EKS makes it easy to run Kubernetes on AWS without having to manage API or a control plane or the etcd nodes. In this session, we show you how Amazon EKS makes deploying Kubernetes on AWS simple and scalable, including networking, security, monitoring, and logging. And lastly, we will cover how to set up CI/CD for your applications deployed on Kubernetes. So for new folks who are not familiar with Kubernetes, just to take 15 or 20 seconds on what Kubernetes means. So Kubernetes has been around for a few years now, but it has absolutely taken the world by storm, especially over the past 12 months. It's also rapidly gained traction among AWS customers. So if you take away the hype and look at its core, Kubernetes is an open source container management platform. It's built to help you run containers at scale, and it comes equipped with features and functions to build proper distributed applications using 12-factor application pattern. So why do developers love Kubernetes? I think there are three main reasons for it. The first thing is the community itself. It has an amazing and enthusiastic developer community, and it's one of the most popular open source projects on GitHub. If you take a look at the repository on GitHub, it has more than 37,000 stars, almost 70,000 commits, and more than 1,600 contributors. And the second thing is Kubernetes can run anywhere. It can run on-prem or it can run on a cloud platform. Now, many customers that use Kubernetes today, they like it precisely for this reason. Either they might be making some investments on prem now, and they might have legacy applications that are running on-prem. So what they can do is they can run Kubernetes on premises and migrate those legacy applications into containers, build their applications in a cloud native way on-prem, and then move to the cloud when they are ready. And last but not the least, the Kubernetes API can be thought of as a single extensible API that can be used to abstract resources both within AWS and on-prem. When using Kubernetes on AWS, you can take advantage of scale and performance and breadth of the features of AWS platform via Kubernetes cloud integrations and use the same familiar Kubernetes API when deploying containers on premises. Now, another thing to note, when CNCF, which is the governing body for Kubernetes, when they did the survey, we found out that 57% of the users deploying Kubernetes workloads actually run on AWS today. And this was actually a good data point for us to start working with the customers and start thinking about making some investments in the Kubernetes community. And when we started talking to those customers and asking them what's their biggest pain points, they actually told us that managing Kubernetes API endpoints like the masters as well as the etcd nodes is actually hard when you start running workloads at scale. And this is why we started working on Managed Kubernetes Service, which is called EKS. So let's take a look at some of the Kubernetes setup choices that you have on Amazon. Now, if you need a simple development environment, you can use a tool called Minikube, which is actually sponsored by Kubernetes community, and there's active development there. What you get with Minikube is you get a single node Kubernetes cluster, and you can quickly stand it up on your laptop and work with your development activity on a day-to-day basis. But if you want to stand up like a production grade clusters where you can run applications at scale, there are two other choices. One is community developed, which is Kops. And this is pretty actively used among AWS customers today. And it has a robust set of features and integrations with AWS services like auto-scaling, ELB, etc. And the other choice that you have for enterprise-grade Kubernetes cluster management platforms are, one of them is EKS, which is actually went GA as of last week, which is June 5th. But there is also CoreOS Tectonic and Red Hat's OpenShift. So these are multiple options that are available. Plus there is capabilities either provided by the same tooling like Kops or Tectonic or OpenShift. They give you the flexibility to work with tools like CloudFormation as well as Terraform so that you can manage your Kubernetes environment using these tools. So let's take a look at Kops real quick. So Kops is it's a community supported, it's an open source based platform where you can spin up your Kubernetes environment, and it is managed by SIG AWS community. And it can also give you a capability to create your Kubernetes platform using CloudFormation or Terraform scripts. And it's available on GitHub, so you can take a look at the code and customize it for your environment, and also actually contribute back to the community so that a wider audience can make use of your code. In order to see, how to create Kubernetes infrastructure, you can take a look at the command line there. First thing you need to do is specify your availability zones. Once you do that, you specify your state store, and then you can create your 3 master node with 5 worker node cluster with the desired EC2 instances in those availability zones. So let's talk about EKS. So when we offer, so EKS is managed, it's a managed Kubernetes control plane. And what you get by EKS, it's a highly available API server and etcd. So if you're familiar with the ECS environment, EKS is a similar type of implementation, and in which way you can bring your worker nodes into your EKS cluster and manage your EKS clusters that way. And I have a few slides later where we talk about what does that EKS control plane looks like. And here are some of the core tenets that we used in order to give EKS or Kubernetes experience for our customers. And the first thing was we wanted to build a service that is enterprise grade so that customers can bring in their production workloads onto the EKS platform. And also the experience that you see with EKS, Kubernetes experience, is the same as you would get with other Kubernetes implementation. And the other thing to note here is we're not forcing you to use any other AWS services, but if you needed to use other AWS capabilities like a load balancer or Route 53 to manage your DNS entries, those integrations are already built by the community and they are available to consume for your workloads. And lastly, the implementation on EKS is actually Kubernetes conformant. It's a certified Kubernetes conformant. So if you wanted to run your Kubernetes workloads, that's an assurance for you to run and get the same level of experience on EKS. And lastly, one more thing to note here is the teams that are involved in building EKS are actually actively contributing back to the Kubernetes project. So you'll see a lot of these features coming closer to the Kubernetes community in general. So let's take a look at the underlying EKS architecture. So what you see here is when you go and provision your EKS cluster, you'll see a set of API servers that are spanning 3 availability zones and etcd nodes that are also spanning 3 availability zones. The main reasons we want to keep it running on separate EC2 is because of the blast radius. It goes back to the Amazon principles of building a managed service. And it also gives you a highly available nature for consuming the service because of the way it spans multiple availability zones. So once you have your cluster provisioned, what you get is an API endpoint, and then you can go ahead and bring your worker nodes by attaching or running it in multiple availability zones, and you can interface with that cluster using Kubectl, which is a CLI that you can run on your laptop, and you can deploy your Kubernetes workloads onto this EKS cluster. So how does it look like in terms of creating an EKS cluster from 0 to launching your workloads? So it actually involves 3 major steps, and then you can go ahead and deploy your workloads. The first thing is you go and create your EKS cluster, and then you bring in your worker nodes, your EC2 instances onto your EKS cluster. And then you can launch your add-ons, and these could be plugins like Prometheus, or capabilities like Service Mesh, like Istio or Envoy. If you wanted to manage your Kubernetes environment using community-developed plugins, you can do that. And then you can go and build your workloads onto your EKS environment. So underneath, when you go and provision that cluster, these are the steps that happens on the control plane. So what we do is we go ahead and create a highly available Kubernetes API. That's what you saw earlier in terms of architecture. We spin up 3 API servers in 3 different availability zones. We also provision etcd nodes, and we also give you a capability to integrate with IAM, as well as certificate management. And then we also take care of auto scaling and give you a single endpoint using a load balancer, which is actually a network load balancer that you'll see in the next diagram here. So you can see here, you get your EKS control plane that is running on EKS VPC, and a set of worker nodes that are running in your VPC. And in order to become Kubernetes conformant, we had to do a couple of implementation in terms of networking, and also to give you the capabilities like Kubectl logs or exec or proxy. We had to inject in ENI that comes, it's a cross-account ENI coming from a VPC that is managed by EKS control plane onto your customer VPC. And that essentially gives the communication path for the API servers to talk to the worker nodes. And the other side, whenever your Kubectl or your worker nodes tries to talk to the EKS control plane, they talk to the network load balancer. That's the endpoint that is available by the EKS API. Now let's take a look at the demo real quick. So what you see here is a management console. This is EKS management console, and in order to get here, what you can do is you can type EKS and click on it. And if you see the console, there's not much there because we wanted to keep it pretty simple for a Kubernetes customer, and essentially give you the capabilities to create cluster, describe cluster, or delete cluster. So if you look here, I've got a cluster that is running. The cluster is named as demo. And if I want to create a cluster, I will click on create a cluster. So this is using the console, but there's also a CLI method in order to create a cluster. But let's go ahead and create a cluster. We'll call this webinar demo. In terms of versions, you see the current GA version of Kubernetes, which is 1.10, but there will be more available as Kubernetes make those versions available. Then we go and pick a role. In this case, this is a EKS service role, which I already have created. So I'll pick that. And then you have to select a VPC. So for this implementation, I'm going to choose EKS VPC that I created earlier as a prereq, and select your subnets. Actually, let me go ahead and select the subnets. So once I have my subnet selected, I can go and select my security groups. And this is the EKS created security group, so I'll go ahead and select that. This is for the control plane to talk to your worker nodes. So once I have all of that, then I can go ahead and say create cluster. It takes about 10 minutes to go ahead and create this cluster and have the environment ready for you. But once you have the cluster created, you'll see the status change from creating to active. So let's go and take a look at our cluster that is already running. So if you see here, there's a certain level of information that is important. So first thing is the API endpoint. So this is the API endpoint that you will use within your Kubectl configuration. So when you edit your kube config, this is the information that you will need. And there's also some security related information like security groups and certificate authority that you'll need. But once you look at the EKS Getting Started guide, you'll have the EKS cluster created and configure your Kubectl. And once you have all of that, you can essentially run Kubectl cluster info, and you'll see that I'm currently connected to this cluster for this demo purpose. So let's go ahead and make use of this. So we have a cluster ready, but in order to create our worker nodes, we have a CloudFormation template that is available on our Getting Started guide. So I've already done this. I've created 3 sets of worker nodes. and I've also configured my config map, which I will cover later in the presentation. So once you have all of that configured, if I do kubectl get nodes, I should see 3 sets of EC2 instances, which are my worker nodes that are part of my demo cluster. Now let's go and launch a simple workload on this cluster. So what I'll do is I'll go ahead and create an Nginx as a deployment. We'll take a look at that code real quick after I get these created. And what I'll do is I'll go ahead and create this Nginx environment, the deployment that I just created, and I will make it available as a service. All right, so I get a response saying both my deployment and my service is created. So if you go and say kubectl get pods, I should see 2 pods running. Say kubectl get service, which is SVC as short form. I'll see my Nginx is running and it has a load balancer attached to it. Let's take a look at the code real quick. So if you see nginx.yaml, it's a pretty simple application. It's an Nginx application that is that runs Nginx image. It attaches port 80 to it and creates a couple of labels and runs 2 pods using replication controller. And it uses a Kubernetes construct called deployment and makes that deployment available. Now if you look at Nginx service, you'll see, well, I take that Nginx environment that I just created using deployment, and I create a service, which is another Kubernetes construct. And while I create that as a service, I also go and attach a load balancer to it. So if you specify type load balancer in AWS environment, it makes use of the Elastic Load Balancing service. So if you go and say, give me that load balancer endpoint using kubectl, then you see that it's got Elastic Load Balancer created. So if you go and open that up, you should be able to see an Nginx server running. So that's a pretty simple demo that I wanted to show in order to give a simple experience. It's a pretty straightforward example, spin up an Nginx environment and then run it on a Kubernetes cluster that is managed by EKS. Now let's go back to the presentation. Now the first thing that I want to cover here is networking portion of EKS. So when we started thinking about building EKS as a service, we thought about writing a special plugin, which is a CNI plugin. And we actually thought, let's make this available for the Kubernetes community in general. So this CNI plugin is not necessarily just for EKS, but it is for other Kubernetes implementation as well. And what the CNI plugin gives you is the same native VPC experience, which is essentially a construct that is on top of EC2. And that's one of the principles that we thought of when we wrote this plugin itself. So the networking that is going to be available on pods, it must support high throughput and availability and low latency and minimal jitter that is comparable to the characteristics of customers that would who would get from EC2 networking as well. So we wanted to give you same level of experience as you would see on EC2 onto the Kubernetes pods as well. And by doing this, you also get the features that are available on VPC, such as VPC flow logs. And if you wanted to troubleshoot your flow logs using VPC flow log feature. That's going to be available for Kubernetes pods as well. And if you wanted to control your routing policies using VPC routing, VPC routes, that capability is available for Kubernetes customers. And this VPC CNI plugin is available on GitHub. So if you wanted to take a look at the frameworks that are laid out and get to the implementation details, you can do so later. So here, what you get is it's a thin layer. There's no performance impact, and the IP addresses that you see on pods is actually the ENI secondary IPs. And you'll see a few more slides that talk about this more detail. So here's the general schematics of CNI. So when the kubelet that is running on a worker node, when it runs on, when you start that worker node, it goes and queries the CNI specifications. And if it sees that in terms of EKS, it runs AWS CNI plugin. And once you have that running, it gives you those CNI capabilities that I spoke about earlier. And in order to run it on other Kubernetes implementations, all you need to do is just run that VPC CNI plugin as a daemon set. So here's the implementation details on what actually happens when you specify VPC CNI plugin. So once the AWS CNI plugin is installed, the plugin will create ENIs on the instance, and as you create pods, it attaches secondary IP addresses to those pods. Those IP addresses show up as a v8 interface on those pods. And that's the reason you see the IPs that are attached to the pods are actually VPC IP addresses. So the communication between the VPC CNI plugin and the local IP address manager, which is local IPAM, is gRPC. So we make use of the local IPAM here in order to maintain the warm pool of secondary IP addresses. So as you provision your pods or services on a given worker node, the LIPAM will watch for the threshold that is available on that warm pool of IP addresses. And if it runs out of threshold, then it will go ahead and provision additional set of ENI and the IP addresses, the secondary IP addresses that come with that ENI. So that is actually implemented pretty well in the CNI plugin. And if you're curious about, how does the pod-to-pod communication work, you can take a look at the life of a packet here in this implementation. So here on the right-hand side, you have a pod that is already available. Let's say you go and launch a new pod, which is shows on the left-hand side of the EC2 here. And the VPC CNI plugin will go ahead and create two v8 interfaces. And it will attach a v8 interface to the pod namespace and create a v8 interface for the host namespace. And then it goes and create a route between the pods and the host namespace. And then it creates the routing table for both of those and attaches the v8 interface to the ENI. And now both the pods can communicate with each other using that communication channel. Now if you want to see how does the pod communicate with the external network, in this case is the internet. but if you wanted to begin to connect to your workloads that are running on your on-prem environment using VPN or Direct Connect, similar type of implementation works. So the plugin will actually create an IP table's SNAT rule using the primary IP address of the ENI, which is then forwarded to the VPC's internet gateway in the case of external network communication like the internet, or it gets routed to the VPN gateway in terms of VPN or direct connect communication. Now, like I said, this code is actually available on GitHub. So if you wanted to contribute or raise issues, contributions are welcome. Now let's take a look at identity and access management and how is IAM or security is implemented on top of EKS clusters. So for this implementation for IAM, what we needed to do was we work in collaboration with Heptio in order to come up with a plugin called Heptio Authenticator. And this is also available on GitHub. And let's dig into how this works. So in this case, let's say if when you do a kubectl call and say kubectl get pods, then what Kubernetes does is it takes the IAM identity that you pass with kubectl. It authenticates your IAM against AWS Auth, and then it passes once you're authenticated, once we know who you are, then you're passed on to the Kubernetes RBAC, which is a native RBAC implementation. And that's where you are authorized against. That's where Kubernetes will check whether you have the right level of authorization. So in my case, when I say kubectl get pods, Kubernetes will check whether I am allowed to do that call or not. And then I'll get my response whether if my action is allowed or not. So in terms of workers, this actually happens when you provision a worker node. If you see the EKS documentation, you'll see that during worker node provisioning steps, we ask you to create a config map. And that config map actually has the AWS auth info. And when it gets applied, the worker nodes are able to join the cluster, which then enables kubectl to work with the Heptio Authenticator. Like I said, this code is also available on GitHub, and contributions are welcome to this plugin as well. Now, let's take a look at how you would get visibility into your cluster. So in terms of visibility in a Kubernetes environment, it means several different use cases. It can be getting the logs out of your environment. It could be master logs, cluster logs, such as audit or scheduler logs. It can be metrics. How is my worker nodes performing under load? It could also be events or alerts or application tracing for your container workloads. So let's talk about how you can implement a log implementation, a log aggregation on top of your EKS environment. So here's an implementation that you can see. You can go to GitHub page in order to find more information. What we showcase here is you run Fluentd, which makes use of Cloudwatch plugin. So as your so you run Fluentd as a daemon set on each of your worker nodes, and your containers will write all the logs to those Fluentd daemon set. And as they start writing, they will start showing up on AWS Cloudwatch Logs. So in terms of metrics, you have lots of options available on Kubernetes. So if you wanted to use a node exporter in order to ship your metrics, that's available. If you wanted to use Prometheus in order to get a monitoring environment so that you can aggregate all the metrics and have a single dashboard for monitoring your cluster level as well as container level metrics. So that capability exists. You can also make use of InfluxDB or Graphite for your data model. You can have a visualizer such as Grafana or Kibana and have dashboarding capability for your metrics. So that all of these capabilities are available for Kubernetes implementation. And also on the EKS side, so you can have these plugins and capabilities enabled on the worker nodes and have it running in order to get the metrics from your EKS cluster. Now let's look at how you could implement a CI/CD for your applications that are deployed on Kubernetes. So if you have a development team that is using CI/CD in order to push their applications onto Kubernetes, so you have Jenkins that is available, but also you have written a reference implementation that makes use of AWS Code Star Services, which is AWS Code Pipeline, Code Commit, or Code Build Services, which I will walk through in our next slide. But there's also lots of AWS partners that are available, such as GitLab, Shippable, CircleCI, as well as CodeShip. So you can use any of these CI/CD. Okay, so let's take a look at how you would build a CI/CD implementation using Code Pipeline, Code Commit, and Code Build Services. So let's say if your developers go and push a new code to a Code Commit repository, Code Pipeline will pick that up and trigger a pipeline workflow and go ahead and build a new version of your Docker image using code build. And then it would go ahead and push that image to the ECR repository. Then it would go and invoke a Lambda function, which will actually go and trigger an application deployment to Kubernetes using the Python SDK. And then that would go ahead and fetch a new container image from ECR and deploy it on the Kubernetes environment using a rolling update. So this code is actually available for you on the GitHub page. So feel free to take a look at that. So what's next? So I recommend for you to take a look at our documentation, try out the EKS service and see how the experience is. And if you wanted to learn about some of the Kubernetes tutorials, we have put together learning paths that is available on a Kubernetes workshop. That is github.com/AWS-samples/AWS workshop for Kubernetes. So take a look at that, and there's different learning paths for developers as well as operational, and there is also a general learning path where you'll get to experience some of this deployment and build the containers, build services, as well as complex deployments. There's also integration with the code suite that I mentioned earlier, but also integration with other services like X-Ray. So take a look at that and contribute back to the GitHub repo if you have any recommendations. Thank you. We'll take a few minutes and answer a few questions that are coming up in the chat room here.